Hello, welcome to this tutorial of the magic bridge in Houdini with Unreal. So what you see here on screen is what we're going to make, and I hope you will see how easy we can get this with Houdini in Unreal. Now, first steps of this tutorial is that we need to build a scene. So I've already made a scene. I'm not going to cover how to build the scene. So this is purely built with Megascan. So if you would be new to this, we can just here go to Quixel Bridge, and then we can open a library of pre-made assets, like for example, this bridge model. As you can see, this is just something you can just find. So you can get the same bridge if you want to. So here it's called Japanese Stone Bridge. So you'll find the same one if you want to use the same bridge. And then for the rest of the models, they are just these rocks that I've used and some of these other parts and floors. So that's basically the first step. Is you need to build a basic scene, or you can just, for example, do the bridge alone. But if you want to make it a bit nicer, you can just build like a quick scene with like the mega skins. So once you've done that, I would then recommend basically sort of like selecting everything. So either you can, for example, select here like so. You can select all the assets. And what we want to do with that is we want to just have all this information or have all these assets and the placement of these assets into Houdini, so I know how to then collapse my bridge and then collide with the scene as well. So a cool trick here is that we can just say here, export selected. It will basically convert everything that we selected into an FBX file, which of course is what we can open in Houdini or any other software if you want to use it somewhere else as well. So now that we are in Houdini, we're going to start to make our simulation. So we're going to first of all need to bring in our FBX file. So what we need to do with that is we need to type in file node. So this will create a geometry network first of all. So here we are on object level, but we also have geometry network. So we want to go inside of this geometry level. So now we are on geometry here, as you can see. And in here, we then want to load in our asset. As you can see, this is my asset with everything it has. So we have the bridge and we have all these other objects. So in Unreal, I made like a shader cut with like a sphere, but here we don't have that. So what we're going to do is we need to extract the bridge. So I will use a splitting node. So we want to split these two parts. So here I'm just going to go in the splitting group and say I would like to select this part, press enter, then we have our bridge. So now we have two outputs. So this part is the bridge. This part will then be used for collisions. So what we need to do with this is that we actually need to make sure that this is actually a closed off mesh. So we need to type in a fill and we're going to use the polyfill. So this will actually close off the caps and you can choose the method of having quads or for example having triangles. So this is now a closed mesh, which is of course preferred with the simulation. With the shape closed, we can now start to fracture this, and we can use the material fracturing node. This is a pre-made node that helps you with fracturing objects. So here, if we just plug it in, it will take a second and it will actually fracture this mesh. So it might not look like it's been fractured, so that's why sometimes we would like to use the explode node. And this way we can, as you can see, we can clearly see for example, the fracturing parts. So these are now all fractured pieces. So usually you would play around with this a bit more. We can also have different levels of fracturing. Let's just keep it way simple for now and just say, for example, 1. And we're going to increase the amount. So we want to, for example, have 300 points scattered, which will return into, of course, more pieces. And we can also here have noise typing, which if you can play around with, will react differently on how the things are calculated here. So there are a lot of settings you can play around with here. But for now, this is already good enough. We just have a basic fracture. Now, what I also like to do, so you don't need the explode node anymore. This is just for visualizing it. What I also like to do is using the assemble node. So the assemble node itself will basically pack the geometry. So if I create here pack geometry, it will just basically now collapse every unique piece into a point. So as you can see, we just have a bunch of points here. So we don't actually have real geometry because they are sort of like packed versions of that. Now, what is useful with this is that I exactly know how much I have. So if I hold middle mouse, I can say that I have 310 pieces. This is important to know for optimizing because the more pieces we have, the more trouble we will have to get this in game engine. So if let's say you have like 10,000 of this or like 50,000 of 50,000 pieces, we will basically have a lot of trouble bringing that into game engine. So I recommend always like double check how many pieces you have for games especially. Once that is done, we are basically ready to plug in a simulation. So we're going to say bullet solver. So this is for the rigid bodies. And we're going to plug in our object here. And if we just now would go to our timeline and press play, it would just probably, as you can see, fall like that. Now, one mistake that I already made here is that you saw that the bridge is falling quite slowly, and that is because of the scaling difference. So whenever we import something from the game engine, we actually need to do a transform, and we need to scale this a bit lower. So if I now would press my grid, we can see that we have a quite high units in scale. So there is about 100 units difference, so we're going to have to say scale by that amount. So we're gonna scale it 100 times smaller, as you can see. So that's actually now the proper scale. And that will also, again, have an influence here on the simulation. So as you can see now, the bridge is sort of like falling in a more normal way. Now, with this ready, we also, of course, want to include collisions. So you can here add, for example, a ground plane, and then it will fall on the ground. But of course, we have here our custom colliders. So here, if I would place a null node, we can see our collisions. We can, for example, then call this collisions. And we can now plug this in over here in the collision geometry option. So let's now take a look at our simulation. And as you can see, it will just follow on our collision objects. So that's exactly, of course, what we want, is the pieces need to be falling on our collision object. Now here under collision, here are some options for your collision if you have like any specific needs. For example, here like the geometry representation is, for example, set to convex hull, but you can, for example, change this if you find that your geometry is a bit more complicated. Then you maybe want to switch that out to have better results. So you can play around again with some of these settings. So now that is done, maybe I'm just going to set it back for now. We have our basic simulation, but we want to have like this magical bridge deformation. So how are we going to do that? Now, there are a couple things we can do, and one thing is that we can just double click on this node, and we are now opening this whole new layer. And here we have some nodes that's saying that we have the option to use pop forces in the pre-solver and in the post-solver. So what we're going to do is we're going to add some forces here in the pre-solving to actually make an interesting effect. So let's say I would like to have my pieces to be attracted to a certain point. So when a simulation starts, instead of just falling down by gravity, they need to be attracted by a certain force. So that's what we're going to do. So we're going to type in pop, and these are all the pop options. So these are for particle operations. So pop attract. I'm going to just plug it in like so. And we need to set the force as well. So let's say maybe just 10. That will probably be visible. And second of all is we need to set the point. So you can just click on the handle and you should see a handle. And this is then the actual force point. So let's say I put it here in the center. You can also just manually fill in the value under goal. And if I now would press play, we should now see that our pieces are sort of like flying and sort of like trying to merge to that point. And that is how we can basically use something like a pop attract force. Now, another interesting note that I definitely want to talk about, and what I'm actually going to use for the final result, is something which is, of course, again called a pop node, but this one is called the pop axis force. So you can keep plugging, for example, these like so you can have like multiple forces trying to build a certain effect. But in this case, we are just going to use the pop axis force only. So you know that you can actually plug multiple nodes into each other, have multiple forces react with each other. So what we're going to have here is we're going to have this circle. And this is where we're going to have sort of like this axis movement. So in our case, we want to make the circle a bit bigger, so it actually is like fully wrapped around our bridge. So let's here increase the radius and the height, so we can definitely see what's going on. We can also move this either up or down, but for now, let's just keep it on the bridge. So we're going to go then to speed option because we want to control the speed of it. So by default, it might not be that noticeable. Like you can see, it's just too small in speed value. So we need to go in here and I just immediately set this to 10, and you probably will see a force happening. And this is then our new result. So this is again called a axis force. So it will rotate, or as you can see, it will orbit around our axis here. So it will orbit around that area. So if I would rotate this, it would then just fly in the other direction. As you can see, it'll just fly these pieces in different directions. So this is pretty cool to do. As you can see, there's a lot of options we can now play around with. Now, what I will do for the final simulation, let's say I'm pretty happy with what I have, is I'm going to here cap the frames to a certain amount, let's say 120. I think that's be enough for us. I'm going to play the simulation. So we have all these pieces. And what I will do in Game Engine is I will actually do a reverse. So here we can actually use the labs simple retiming node. And we can here use our reverse option. And this is then basically what can happen if you just reverse it. So it will look like your bridge is like being built, like so. Also important if you are working with this timeline, if you click on this icon here, so on this icon here, you can have a real-time playback. So I recommend turning this on because this will try to make sure the real time is on, so 20 frames per second. So here, this is actually like the normal speed of things. So in Game Engine, I will also build a curve way where we can actually control the animation of the curve. So the useful thing about the curve is that we can, for example, say that this needs to go faster and this needs to go slower, for example. So we can play around with these things. So here it now goes a bit slower and we have then the bridge. So that's how we will do it in the Game Engine. So now let's focus a bit more on our simulation. So let's build a bit more structure around it. So here, let's go back. We're going to now have our pop forces. And what we can do is we can, of course, here maybe lower our orbit speed. And let's play around here with the lift speed. So what does this do? So increase it a lot so we can actually see it. And usually you will see it here. So lift speed will just basically, as you can see, sort of like lift it up along that axis. So if you increase this value a lot, you can see that the pieces are just immediately like flying off the area. So don't bring this too high. Maybe some lift speed could be nice. And then here we have then suction speed. So this will then force the pieces to the point. So here, as you can see, we'll just like force the pieces to be still around that axis. So this can be quite interesting to combine with lift speed. So lift speed will just make sure the pieces sort of like move along the axis, and then the suction will say like, hey, just keep a bit more longer to that axis. So if we combine these two a bit, we will have then something like this, where they should just fly off the axis. And then when they are out of the orbit, they just like break up. And then we can just go back and let's see how that would play in reverse. And then we have a simulation like that. So by now I hope you can see the possibilities of what we can do with some of these settings. So at this stage it's just mainly playing around with things. Maybe I can just move this up a bit. Maybe we can have less forces here. This looks pretty cool to me. This could be really nice. So let's see how that plays in reverse. So because in Game Engine I would just reverse it. We have something like that. What is also interesting to know is that we can also, of course, still play around with collisions. So we're not definitely bound to what the collision that we have here. So let's say, if I look at the simulation here, let's say there is like a certain sphere maybe colliding with it to break up the shapes a bit more. So here we can, in the air, if I would view my objects here. So let's say that above the bridge is something, a sphere like this. And let's see how that would react in then the simulation. So let's reset our simulation. And now we should see this big collision. And let's play. And normally this will then help, as you can see, like break it up a bit more We will wrap around this. And let's see how that would look in reverse now. That can, as you can see, like help to break things a bit up, or if you feel like you need to have like more see-through to the object, it might be able to do that here, as we can clearly see through more of the objects. It's more of like a tornado now as well with that sphere hole. You can always go back here and play around with the amount of pieces. So let's say we don't want that much, we want less of them. We can just here lower that, and we can recalculate the simulation like that. So this is a quite flexible way of working where we can just plug in our own shapes and so on. What we can also do with the simulation is here we can start to deactivate this. So when I deactivate this, it will just basically do a normal simulation. So this way I can, for example, say that, hey, if the frame number, which is a $frame, if this would, for example, be higher than a certain number, then we either disable or enable the activation. So let's say 90. So at a certain point when it, for example, jumps over 90, it will disable. So let's look at that simulation. And it will almost disable. And as you can see now, it just like falls down. So that's like a really useful way, as you can see, to like blend a bit everything together. So if I would reverse it, so everything just now lays down on the ground, and when we play it, it sort of like jumps up in the air and then forms the bridge, as you can see. That's also just very useful to know about. You can, of course, right-click and go to keyframes, and you can say, I want to have a keyframe. So that's also possible. So you can set keyframes as well, which of course I did not do. I just create a logic. What is also important to know, so we sort of like basically have our simulation, but what about our UVing? So we need to actually do a UV step here. So that if we look at our UV, this looks normal, but if we start to explode our UV or explode the object, you will see that our new geometry pieces are having these weird UV information. So let's build a system for that. And there are many ways on how we can do this. I will just do a loop for that. So I'm going to loop over each piece, and I can control exactly what happens there. So we're going to say loop over connected pieces. And we will just basically, as you can see, we will loop these 200 times because we have these 200 pieces. And in there, what we want to do is I'm going to use the auto UVing option. You can also use other unwrappers like the flatten node or the unwrap node. And we're just going to plug in the auto UVing. And we're going to say that we only want to have the auto UVing or the UV recalculate on the inside pieces. So here we can get the inside pieces. So we're only calculating the UVs there. Then we want to fuse this back because sometimes it might happen that if you use the group here, that it might detach pieces. So we will do that. And then we will do a UV transform as well. But maybe let's just see how that would look like here. Maybe let's loop over piece number 1. So here I have piece number 1. Let's check our auto UVing, which looks like this. So this is the UV for that. If you're not happy with the results, you can always play around with the methods. As you can see, we have different methods that we do the fuse. And now the thing is that we want to place this in a logical place. So if I look back to my original piece here, maybe this one. So we can see that we have a decent UV layout. And now we want to do a UV transform. And we here want to transform or move our UVs based on what could logically fit. So I will scale this down. And it sort of like has to fit here in this area, or for example, this area. So maybe I'll scale it down even more, like so, and I will place it here. And again, we have to say that this only is for the inside pieces. So whenever we create a fracturing of the inside, we're going to basically like place it over here. And let's check for each loop. And as you can see, what will happen is it will basically now stack up all these UVs over here. So it's like one solution of doing that. So if I now would do UV explode, so if I would now explode the pieces, you can see that they are now have a more proper UV, and they will actually be way better in the game engine. So with that, we're going to have to just overwrite that over here and place it like so. And that was it for this video. So we handled the simulation in Houdini, and I'm going to make another part where we're going to then handle the simulation or prepare the simulation to be ready for Unreal Engine. So I hope you enjoyed this video. Thanks for watching. Feel free to like and subscribe. See you in the next one.